get you introduced to some of the key features which we are already having as a part of OpenSDS project. So let's quickly get into the use cases. The first use case we are going to have is about enabling SODA services for Kubernetes cluster. So as all of you know, Kubernetes is one of the most popular container orchestration system out there. So anybody who want to support or be in the ecosystem, so it will be always there. One of their main goal is to go with any of the container orchestration system, especially Kubernetes. So this is the architecture diagram which you have already seen in some of the earlier presentations. So we have a platform, we have compute guys, we have a storage guys. So the use case we are going to tell is about the Kubernetes, which is a container orchestration system, how it provides storage solution or the storage provisioning for the Kubernetes workload, and how the system works with Kubernetes plus OpenSDS along with the backend storage. So actually, Kubernetes, like Sanil mentioned, Kubernetes follows container storage interface for storage provisioning. So anybody who wants to claim themselves as a CSI driver, so it's very simple, just follow the language which CSI mentions. So the two end of the communication, one is a container orchestration system like Kubernetes and other end is a driver. So if you visualize OpenSDS as a CSI driver, then this is what it is going to look like. So when OpenSDS is running as a CSI driver, so it is going to run as a microservice with different pods, which is nothing but the grouping of containers. So one thing which Kubernetes made life easy for others is like Kubernetes has provided what is called as sidecar containers, which is nothing but helper for any CSI driver, so that they can seamlessly communicate to the Kubernetes system, irrespective of what changes at the Kubernetes system. The helper container or sidecar containers are always maintained by Kubernetes, released with the versions, so that our storage logic can be intact irrespective of whatever changes happen to the orchestration. Okay, so when we start using this system, two things come into picture. The first one is the preparation or the storage provisioning. Second one is usage of the storage in your workload. In this case, it's a K8s workload. So left side, what you have mentioned is the preparation, that is provisioning of the volume, which is from the OpenSDS side, and right side what we have is the user flow. So as we know, Kubernetes runs as in the Kubernetes we run a workload as a pod by mentioning in some YAML file, and Kubernetes actually one of the design principle of Kubernetes is workload portability. So what they have done is they have separated the volume demand against volume demand against the volume provision, so that the demand can remain same, the provision can change based on the underlying system. So as we know, we start claiming the volume through PVC, which is nothing but persistent volume claim. So user creates the workload mentioning the persistent volume, and we have next, it enters into the OpenSDS system. The K8s CSI plugin is what we call as a northbound plugin, which enables us to enable the container orchestration system to use the OpenSDS. So once the K8s CSI plugin is called, the flow is inside the system, then the OpenSDS takes care of contacting the backend, whichever is mentioned, and provisioning the volume provisioning the storage for that use case, for that workload. So we have one demo mentioning how K8s workload can use OpenSDS provision storage. As we mentioned, this is how the K8s OpenSDS is running as an installer, CSI driver. And from OpenSDS side, we provision the volume. So we have created a profile and mentioning the storage type as a block, which we are interested in attaching. Next, we are going to create a Kubernetes workload, which many of you may be very familiar. We write a YAML file and we write what are the Kubernetes objects needed for that YAML file, and we are going to execute it through the kubectl command. Okay. So our YAML is ready. We are going to create a workload through kubectl command. So that's where we are. So let's wait for a few minutes or few seconds for the workload to come up. As we are seeing here, there is something called storage class, persistent volume, and pod. These are the things which are created. We are going to see it next once it is up and running. Yeah, we can see it, the pod is up and running. We just try to get inside the pod and see the things we are interested in. So before that, the Kubernetes objects that are involved here. We have something called storage class where we mention who is the provisioner. So we can see we have a storage class mentioning OpenSDS as the provisioner, and we have a persistent volume. So this volume which is going to be given as for the demand provided by the PVC. So this PVC is the volume claim which is asked by the workload, and PV is the volume which is provided. And if you look at OpenSDS side, the actual volume which is provisioned here can be viewed through OpenSDS, and we can see by name the volume which is linked from the OpenSDS side to the workload. Let's get inside the workload to see the volume mount points. So we can see like OpenSDS has provided the volume and the path where it is mounted. So this is the way we go inside the container. Let's go inside and check the volume mount point. So there's a volume mount point. And we go to the storage, provisioned storage. Okay, so now what we are going to do is, the application we have run here is Nginx. So Nginx we can access the Nginx, and Nginx, what it does is it goes to a file called index.yaml, and whatever information is present there, if you access the URL, hit that endpoint, it will display that file. So display that content. So what we are going to do is, in our storage we are going to provide that file and see like how this can be utilized by the application for its use case. So we are going to get inside the mounted volume. So this is the file which workload is looking for, just for the demo. So we are going to put some content and then access the application and see the application being using the storage and displaying the output. So in Kubernetes, as many of you know who have used Kubernetes, the way to access the application is by creating some service. So the moment you create a service, we get some endpoint, and we access the endpoint, and that's how we access the application. So let's get the endpoints, and through the endpoint, let's access the application. So it is showing endpoints for the Nginx as IP with the port, and that is the file it has accessed. So this is how we can, this is an example wherein K8s application gets volume, gets the storage provisioned from OpenSDS as a CSI driver and fulfills its volume need or the storage need. There can be similar example with respect to persistencies. You can write a log, we can write a log in this location, the containers can go down, come up, and continue to work with whatever it has persisted. So that's all about the first demo. The Himanshu will take you to the next use case, which is with the VMware. So I welcome Himanshu for that.
Hello. Thanks, Sushant. So this is the next plugin to support SODA services for VMware platform. Yeah. So it basically manages storage resources, provided integrated storage resources management, facilitate storage features like volume provisioning, data store creation, backup and restore, capacity management, and providing the health information of the storage resources. So this is the high-level workflow for creating a data store in VMware. So firstly, the user log in to the vSphere web client to provision a volume. Then vSphere internally invokes some data services and storage plugin APIs for provisioning a volume. Now the vSphere plugin do a rescan of the newly storage changes in their environment for any device discovery for creating a data store. Once the device is discovered, the user can create a data store using that device. So I'll quickly go through the VMware demo for creating a data store. Okay, as I mentioned, that VMware, we can log into the vSphere client. Once we log in, we see the OpenSDS storage plugin in the inventory. The first step is to register a storage platform by providing the storage hotspot controller endpoints and the credentials. So yeah, the storage platform is registered with the plugin. It's ready to use. The next step is to create a volume and attach that volume to the ESX. So this is the step. We can create the volume for OpenSDS resource by providing these parameters, volume name and capacity for the volume. Yeah, so after that, as I mentioned, the rescan of the storage is being done. So to identify the newly attached device to the vSphere, so we can use those devices to create data store. So this is the newly discovered device. We can also verify from the OpenSDS resources. So if we list down the volumes and volume attachment to list down the initiate and the target details, we can shoot these OpenSDS CLI commands to get the information. This is just to verify that whatever is done, yeah. So next step is to create the VMFS data store using that device. So now the device is, data store is created. We can use that data store to provision different virtual machines in VMware to use as per the user requirement. So this is how we, as everyone, if you are aware of VMware environment, we can create a virtual machine using this interface. So we can also list the whatever the operations has been performed all for this step for creation. This is all about VMware plugin. I'll invite Shruthi to explain about orchestration in multi-cloud services.
As we know orchestration, why orchestration is needed? Orchestration is a framework to automate business operations, which will enable organization to improve the user experiences and accelerate the delivery services and reduce the operation costs. So here, OpenSDS, we support variety of service catalog and customized workflows and easy integration of new actions. As Sunil has explained, orchestration is a set of workflows. So let's take one example like volume provisioning service catalog. While volume provisioning, if you want to customize the workflow, suppose if you want to take care of disaster recovery, you have to create a replica of a volume while provisioning the volume. Thereby adding a new action of replica of creating a volume achieves the automation of disaster recovery while provisioning a volume. And in OpenSDS, there are steps to do orchestration. First is register the services by writing a template in YAML or a JSON file, and thereby service catalog manager will be updated. In OpenSDS, internally, it uses the Stackstorm as a workflow manager. So we can create a service instance and we can schedule the service instances for now, or it can be run later to automate all your business operations. So we have another example here, that is intelligent data migration. For that, we have major 3 steps. First is we have to create a migration. Next is execute migration and enforce the migration and get the notification whether it is successful or failure. So we have a small demo of data migration across the cloud. So as you guys know, migrating data from one cloud to another takes user or developer effort to connect two clouds to migrate the data. So here we have a feature in OpenSDS. Through orchestration, we can automate this functionality. So let's go through demo. So we have, this is OpenSDS dashboard. And here we have to first register the backend. We are migrating from AWS to Azure. So we are registering to AWS with all the credentials. So next is Azure Cloud. So we are registering to Azure Cloud as well. We have to provide all the credentials. And now we will move to creating a bucket. First, we will create a source bucket, which is named AWS bucket. So we will upload a bucket object in source AWS bucket. So this is the object we are uploading. After uploading, we can verify in AWS account as well. We can see AWS bucket is created with object whatever we have uploaded. And next, we'll create a destination bucket, which is Azure bucket. So this is the Azure bucket, which will be created in Azure account. Okay, this is empty now. We'll start doing migration. For that, we will create a service instance. This is the orchestration. So we have to create an instance name and a description. And these are the parameters we have to pass. And the description of a parameter and destination backend. We are migrating to Azure backend. So we are specifying along with the bucket name. And we have to specify the data flow migration name. And here one tab is there, remain source, which is true now. That means we can migrate data and keep the copy in both source and destination bucket. So if you select false, then we can move entire data from source to destination bucket. And at last we are specifying the source bucket name, which is AWS bucket. So now instance is successfully created and running is the status. Now it is successful. We can see all the status in data flow as well, the same operation. Here it is succeeded the whatever uploaded object to a destination bucket that is in Azure. So we'll cross-check in AWS bucket that object is there, and we can cross-check in the Azure account as well. See, Azure bucket is there and migrated data is available here. And internally, we use StackStorm. So we can see the status in StackStorm, and we have created 3 workflows, 3 actions. One is create bucket migration, execute bucket migration, and get bucket migration. Along with logs, every details, and whether it is successful or running, every details will be available in StackStorm as well. Thanks. Next, Sushant will be explaining telemetry.
Hello. So the last thing in our demo session is let us quickly get into one of the interesting features, that is telemetry and anomaly detection. Morning, I think most of you have already attended a detailed session on this. So this is how the ecosystem look like. We have a telemetry controller. So we have telemetry controller for metrics. So user third party can log in and get the metrics, request for the metrics. The metric controller will provide you, and the provided metric controller, provided metrics can go to 2 sides. One, maybe that can be directly visualized through some of the visualization tools, or it can also be an input for the anomaly detection flow. So this is the anomaly detection flow which is mentioned in the second half of the picture. And first one is the direct raw input, which is the output of this telemetry controller module. So we have a short demo to see how we can spawn a Grafana dashboard and see what kind of metric we have collected. So So we log into OpenSDS, then we go to our monitor section, and we can spawn a Grafana dashboard. Log into the Grafana. And we can see from our pre-configured dashboard some of the parameters like disk performance, CPU performance, volume performance, and memory usage. So this can be directly visualized, which is a raw, and as well as we are seeing in the picture, this can be input to an anomaly detection system, and better insight can be provided for this raw input. So that's all we have got. So we have many more demos or many more small steps or videos provided for each of the provisions. So you can log into opensds.io and get to know about each of the minute operations which we can do with OpenSDS. Thanks.
Thank you.